Alright, this is the final lesson of this unit, and it is on cubic functions and exponential functions. So we're just going to take a look at each of these, and again, you're going to dive into these a whole lot more when you get to algebra and algebra 2. We're just here to give you a glimpse of them so you can have a familiarity with them and be able to recognize them when you get to higher level math. So for now, let's take a look at cubic functions. A cubic function, just like a quadratic, except a cubic function, we know a cube is to the third power, so it's a little more recognizable because it's of the format ax cubed plus bx squared plus cx plus d. Well, the graph is what I have drawn up there. It's not, we don't have a name for it, it's not a special graph. I mean, it's a special graph, but it's not a special named graph. And you've noticed it goes different, so it comes up, flattens out a little bit, and then continues to go upwards. So that's what all these cubic graphs are going to look like. So again, it's going to be important for us to graph a lot of points to figure out how does this curve and how does it move. Okay? So let's take a look at a specific example of these. So let's take a look at we're going to graph 2x cubed. Oops. 2x cubed. Again, we're going to do a table of values. And again, we want both positive and negative numbers because you noticed it came up, smoothed out, and then went on. So we're going to want some on both sides of that. So let's choose negative 2. Well, 2 times negative 2 cubed. Negative 2 times negative 2 is 4, times negative 2 is negative 8, times 2 is going to give us, is a negative 16. So we don't have to graph this because that is pretty far down there. So negative 2 to negative 16. So let's jump up to negative 1 and see what we get. So 2 times negative 1 cubed. Remember, negative number, odd exponent, it ends negatively. So negative 1 times 2 is going to give us a negative 2. So that is a much easier point to graph. Let's go to 0. So we have 2 times 0 cubed. Well, this whole thing is just times 0, so we're going to go through the origin. Then we jump to 1. 2 times 1 cubed will just be 2. So we're going to get the point 1, 2. And let's do one more point for good measure. So 2 times 2 cubed. 2 cubed is 8, times 2 is 16. So again, this goes much higher than we have to graph. Just gives us an idea of where the point's going to lie. So if I were to graph this, so we end up with negative 2, 16 is all the way down here somewhere. Then we have negative 1, negative 2. Go through 0, 0, 1, 2, and then all the way up here somewhere. So remember, this is coming up, goes through that point, flattens out a bit, and then it's going to continue to move up this direction. Now, it's not as curved here as it was in the example I gave because it's stretched out a little more and it's going higher. Remember to pause the video if you need to. What I'm going to do is leave this up there. I'm going to erase the graph and we'll do a new graph here in a minute. I'm going to put a new table up for my next equation. And this one is going to be x cubed plus 3. So let's put a new table up. let's do those same points. So we have negative 2 cubed plus 3. Negative 2 cubed will give us a negative 8 plus 3. Remember, negative 8 plus 3 heads us in the opposite direction. So that's a negative 5. So that one will be good to graph. We get negative 1 cubed plus 3. So negative 1 cubed is negative 1, plus 3 is going to give us a positive 2. So we end up with negative 1, 2. 0 cubed plus 3 is going to give us just a regular 3. Then we have 1 cubed plus 3. 1 cubed is 1, plus 3 is 4. Now keep in mind, we're not looking for a turning point. Over here, notice that they repeated. They won't always do that, so you can't really look for that in terms of the graph and the numbers that are coming out. So 2 cubed is 8, plus 3 gives us 11, so this is going to be 2, 11. So now that you've had plenty of time to get these down from before, we'll put our graph over here. I don't have many negative points, so I'm going to move my axis down this way a little more. So we start with negative 2, negative 5. We have negative 1, positive 2. Then we have 0, 3. So the Q, as to where does that curve happen, is where the points are really close together. So notice when these 3 points are close, that means that curvature is going to be happening in here. And then we'll go all the way up to 2, 11. So if I come up, we curve it here, and then I continue to move on the upward direction. So that curve happens where the points are really close together. Alright, so let's take a look at an exponential function. We'll first start by defining it. An exponential function is a function written in the form y equals ab to the x power plus c, or we might just have it as y equals a to the x plus c. Okay, so sometimes you'll have a number multiplied by that first term and sometimes you won't. So it'll be either way is okay to write that. But that's not important to us. It's mostly recognizing that these functions, the variable is the exponent. So let's just take a look at an example of one of these. And we're going to see from our example, what does the graph look like when the variable is the exponent. So let's take a look at a graph y equals 2 to the x plus 1. So again, let's make a table of values. We're going to go both positive and negative because we're not sure what's happening here. So I think that bottom piece may be out of your screen a little bit, but I'll read it off to you as I do it. So what happens here is we're going to have negative 2 to the negative 2 power. So remember, when we have a negative exponent, that means to flip it. So that means we're saying 1 over 2 squared, which is 1 over 4. So let me write this a little smaller so that I can actually write this out for you. So we have 2 to the negative 2 plus 1 means we have 1 over 2 squared plus 1. So that's 1/4 plus 1 gives us 1 and 1/4, or we can just write that as 1.25. So we'll end up with negative 2. So notice it didn't go negative, it just went fractional. So now if I have 2 to the negative 1 power plus 1, that just means 1 over 2 to the first plus 1. So that's 1.5. So when we have negative 1, it's 1.5. So then we go with a 0. So 2 to the 0 power plus 1. Remember, anything to the 0 power is always 1. So 1 plus 1 is going to give us a 2. So then we're going to have 0, 2. 2 to the first power is 2 plus 1 gives us 3. So then we have 1, 3 as a point. And then 2 to the second power is 4 plus 1, which gives us 5. So then we have the point 2, 5. So notice, even though we had negative numbers for x, we never had negative y values, right? So that's how this is going to be a little different than what we've been doing before, because not often are they going to go into the negative areas. So negative 2, we still had a 1.25. At negative 1, we had a 1.5. At 0, we had 2. At 1, we had 3. At 2, we had 5. So this is creating a shape like this. So it flattens out down here at the bottom, but then it moves exponentially faster and faster and faster and faster and faster until it's almost just going straight up. So it kind of creates a corner shape almost, but it's a little more curved. And so that's an exponential function. So they are going to be a little trickier because the thing you're plugging in goes in for the exponent, and but again we're going to have less negative y values and we're going to have more fractional y values or decimals with that. So we'll do some more practice with this in class, but I just wanted you to be exposed to what do they look like. So cubics are more along the line shape, but they have that curve in the middle, and then exponentials are more looking like kind of that cornered shape, but with a curve there in the middle as well.